Hello, my name is Nathaniel Bade, and I'm going to be giving a little mini lecture here on feature constructions. Sorry. So hello, my name is Nathaniel Bade, I go by Nate, and I'm going to give my little teaching demonstration today on feature construction and basically as an introduction, so why should we construct features by hand? The sort of review for this material would be that we've already gone through basically data processing and analysis, especially around things like linear regression fits. So we've looked at some data sets, we've looked at tools, we've seen how we can we've seen how we can use So hello, my name is Nate Bade, and I'm going to give my teaching demonstration on feature construction, and in particular, why should we construct features by hand? So the background here in the class would be that roughly like we've gone through some data sets, we've looked at linear regression, we've looked at multilinear regression, we've looked at a little bit of a preliminary data analysis and exploratory analysis. And what I want to bring out here is basically that sometimes that's not enough. Sometimes we need to dig a little bit deeper and use some prior knowledge to really understand the data as more than just numbers. So today we're going to look at the Airbnb review data, so the Airbnb data set from New York. The full data set can be found at Kaggle. I'm just going to use a smaller portion of it that I cut off and I'm hosting on GitHub. Okay, so here we go. So we've got the name of the building. We've got host ID, host name, neighborhood, latitude, longitude, room type, price, et cetera, et cetera. So for this demonstration, of course, there's a lot of rich categorical information. There's some string data that we could try to process, but I just want to look at the numerical features. So just as before, we're going to drop everything except for the numerical features. Display that really fast. We're also going to drop the host ID since that should be random. And we notice that there's some nans here. So we'll just go ahead and clean those out. And since reviews per month, if it's nan, probably just indicates that, yeah, number of reviews is 0. Number of reviews is 0. We could go through and check that, make sure, but I'm just going to fill it in with zeros for each nan. And we can just check. Sum is nan. Great. Okay, and let's take a look then. So at our correlation plot as before. So here we go. We got price. We've got the correlation with all of the numerical features. And hopefully the first thing you notice is it's not good. We are barely pushing above 0.1, and none of these features seem to correlate with the price really at all. Okay, so what does that mean? And this is where we need to think about our features a little bit. So in previous examples, we showed some really interesting stuff that we could do with linear functions. So we showed that we could do things like, recover racial information from medical records just looking at linear fits. But we want to think a little bit more now about what the data is actually, what the features actually are. Okay, so in this case, minimum nights, number of reviews per month, calculated host listings, availability. Well, these are actually all things that might not actually correspond to the price, right? Minimum nights, we have a 5-star hotel that really doesn't have any minimum number, or your minimum number of nights is 1, or the minimum number of nights is 2 weeks. It's not clear. There is one that surprises me though, looking at this, and that's latitude and longitude, right? Latitude and longitude, that's all the spatial information. And we know that spatial information actually matters quite a bit for the price of something like an Airbnb. Like, are you next to the beach? Are you in Manhattan? Are you somewhere off in the boonies in Brooklyn? Like, all of this information should be giving us some information about the price. So why isn't it showing up? And well, we can look at these things, and we do see. So we see actually a couple of killers here. So first, we see that there's maybe some correlation here, but it's not a straight linear correlation, right? A straight linear correlation is basically measuring as we go up, 1 unit in the latitude direction, what happens in the longitude direction. So here, just do a quick plot of our latitude versus our longitude, and our longitude versus price. We also notice that we have a bunch of outliers here, right? So we have a bunch of outliers, and they are, I'm gonna restart this. So hello, my name is Nate Bade, and thank you for giving me the opportunity to talk about some data analysis with you guys. So the idea behind this lesson is basically that we're going to talk about feature construction. It's going to be sort of a first introduction to why should we construct features by hand. The background that's being assumed here is that we've done exploratory data analysis, so correlation, histograms, how to process data, download data, but just at a fairly basic level. And we've also done linear regression and multilinear regression. So for instance, the data sets we would have looked at would be something like, some of the medical insurance information data sets, and showing things like, if you throw a large linear regressor at them, you can drop the race column and predict it with about 85% accuracy. So those kinds of very almost machine learning-y results, but that shows something significant. So here I want to argue for the feature construction by hand view. Okay, so the data set that we're going to look at today is a bit of a standard. This is the Airbnb review data set specifically for New York. You can see the whole thing hosted here. I'm just going to pull about 10,000 records out of it, and I have those hosted in my GitHub, so it's just a little bit easier to work with. And what do we have? So we've got our name, our host ID, host name, neighborhood, latitude, longitude, room type, minimum number of nights, number of reviews. So a good mix of numerical data and categorical data. In this case, we actually have some string data we could try to process in the future. But for now, we're just going to drop everything but the numerical data and take a look at that. So as before, we just do include np.number, and that'll just pull out the numerical stuff. Here we go. We do see that we've got some nans here. In this case, it's reviews per month. And what we notice is actually that we have a nan exactly when the number of reviews is 0. So a simple way to fix that is just to fill in a 0 for each one. So we're going to do here. And we can just go and check and make sure, yes, okay, great. We fixed all of our nans. And let's look at the correlation plot as we've done. Okay, so here we go. We've got price, and we've got the correlation with all of our other numerical features, and it's not good, right? So we are barely seeing any correlation here. And okay, as we look through, maybe this isn't that surprising. Minimum number of nights, that actually might not be that correlated with the price, right? Number of reviews also may not be. It could be a new expensive property. It could be a new property. We don't really know. But there are two, and I would actually argue you can basically argue the rest of these away. For these last two, though, this is a little bizarre to me, right? Because latitude and longitude, I mean, gives a huge amount of information about the price, right? Are you near a park? Are you on the beach? Are you in Manhattan? Are you, way out in the suburbs somewhere? Latitude and longitude should be holding a large amount of information, and yet nothing's showing up. So why is that? So let's just take a look at a scatter plot of price versus latitude and longitude here. And the first thing that we're going to notice is that we need to cut out some outliers, right? There's 10,000 data points in here that we've taken, and this is only about 20 of them up here. We might be interested in them at some point, but probably we're not going to see any kind of nice correlations if we allow these kinds of really bad outliers in there. Second, though, what we see is that there maybe is some shape here that we could detect, but it's certainly not a linear increase or a linear decrease, right? So, and that's really what correlation is actually getting for us, right? It's saying, well, if we increase latitude by this much, how much does longitude increase? And so it's maybe not surprising looking at this that we're not getting a great correlation. Okay, so let's cut out these ridiculous high values. In fact, let's just cut everything above 1,000. That's what we're going to do here. So again, this is just, we just take our data frame and just do data frame of. This is going to be a logical, so we'll look at the price column. We'll say for the price less than 1,000, that'll give us a true value. Everything else will be a false value, and it'll drop the false values out of the data frame. And we'll save this out as something new. Okay. And then let's plot it again. And okay, so we see some more structure. Again, it's certainly not very linear. So what are we actually seeing here, right? Like, why can't we take these and combine them into something? And the answer is going to be that we can. I would encourage you, as a little exercise, just to repeat what we did before and just check that a linear fit on 2 features doesn't somehow magically get us out of this. Just run the code in this case, but in this case, so yeah, our R squared is terrible and our F statistic is nothing. So okay, we're not getting the 2 feature fit doesn't really do anything for us. Okay, but let's take latitude and longitude and plot them together. Let's plot them against each other. And all of a sudden, here we go. We have Manhattan, we have Brooklyn, we have sort of the spread of New York City. Let's add the price in. So as we talked before, we can, if we use scatter plot, we can just specify C is going, we can color it by the price. We'll add a little alpha value in. And here we go. Now we start to see if there really is some localized information, right? There are higher prices out in a lot of different places, but of course, right around Manhattan Island, around Central Park, we're seeing that's where the high prices live. We can actually, just as a quick thing, you could also do a log scale on this. And that would basically normalize out some of the ridiculous, the higher and lower values, so that we'd be going up by a log factor. And you can see that it does give you a sort of a little bit of a better visualization here. Okay, so let's zoom in on Manhattan really fast. And again, how I'm just going to do that is I'm just going to cut out the latitude and the longitude. Just kind of looking at this picture, saying, we'll just cut out Manhattan right there. We'll just cut out the latitude and the longitude. And here we go. So now, but this isn't good enough. Okay, so we've started with 2 lists of numbers, and like we can see that there's structure here. But how do we actually construct a feature in a way that a computer can, read it and figure something out and do some statistics for us? And I'm just going to propose one way. We'll look at a couple of different ways, and I want you guys to think about what you could look at. But one way is to project a hypothesis. So let's say I'm going to say, well, I'm going to assume that the price is actually correlated with the distance from a subway station, right? This is a hypothesis we can test anyway. So how do we do that? So, well, we need to go and get the list of subway stations. Luckily, that's not too hard to do. New York City Open Data Project will do it. And basically, then what we want to say is for the jth property, which is going to be located at some, latitude, longitude, we want to construct a new feature, which is going to describe the distance from xj to the nearest station. So if we have this whole list of stations, so we'll have the latitude I, longitude I, station I, then we can define the sort of the metro distance, the distance to the metro, as the minimum, so for some x, as the minimum from, so with minimum over all the possible stations of the distance from x to that station. So basically, we calculate the distance from x to each one of the stations, take the minimum. And here distance is just Euclidean distance. We could try to be a little bit more sophisticated, walking distance or something, but in this case, it's just going to be Euclidean distance. So the Pythagorean theorem, Euclidean distance. Okay, so we'll dig into how to actually do this in the next section. It's not that hard. But first, let's just look at the results. So I'm going to grab the data. We have to do a little bit of string processing to get it out. And we'll define our Euclidean distance, loop through each of our properties. And this will take a little bit of time to run, but there we go. And let's see what we get. Oh, so it's not great, And in fact, looking at our regression, we see that the F statistic is better, but the R squared is still not great. Okay, so one way to understand this is if we actually just look, so let's just superimpose now all of our subway stations over New York, and we see that, well, okay, so here I've got the coloring again by price, that there just doesn't, there's just sort of subway stations everywhere. There doesn't seem to be a huge correlation that's at least visible to the naked eye of some correlation between the price and where the subway stations are. Okay, So the question is, there's plenty of other features that we could look at. I've actually mentioned some in this demo already. What do you think the best features would be to actually correlate with price, and how would you construct them? So in normal class, what I then do is put everyone in breakout rooms and say, okay, so let's discuss. And I want your group to come up with, three features that you could construct, what kind of additional data you would need to construct them, and then if you have any equations, just give like a rough sketch of the equations. You don't even have to do anything firm as what I have above. And then when people come back, I'd have one or two groups report back and take a look at it. But so hopefully this this has given some intuitive reason to think that when we have prior knowledge, when we know what the data means, again, this is just 2 columns of numbers, right? This is just 2 features of data. And there's this incredibly rich structure to it. And whenever we know what data means, and we know that there's this additional structure, we can try to have a computer just learn it, but we should also definitely consider building those features in by hand. So thank you very much. And if you have any questions, please let me know. It's been a pleasure to present.